97024 October November 2030. The question is question number 7, right? Electrons traveling at the speed of v in a vacuum and incident on a very thin carbon film as illustrated, right? So electron, the thin carbon film, and then it has, the atom is a lot of empty spaces, so the electron deflect, right? And it causes an fluorescent skin. It says the emergent electrons are emergent electrons instead of the fluorescent screen. A series of concentric rings are observed on the screen. So just why the observed rings provide the evidence for the wave nature of particles. As we know, when a particles, as a particle, when it passes through this film, right, it will strike on the screen, but the pattern will not be a proper, right? But if it is a wave, then the diffraction takes place, and as a result of diffraction takes place, it's more dark and light fringes will be formed, right? So it will be like a ring, right? So as we know, the diffraction only takes place in waves, so that electron is having wave in nature, right? So suggest why the observed rings provide evidence for the wave nature. This is actually the duality of particles as electron as a wave and a particle. So when a particle passes through a gap, it will not form a pattern, right? A regular pattern. Dark and light rings form due to the diffraction, and the diffraction occur only in wave, not in particle. So this is the evidence that we claim as the particle duality. It's behaved like a wave. It's a wave property. It holds the wave property, and it of course the particle as well. The initial speed of an electron is increased. Now it is in a particle. The initial speed of electron is increased. State and explain the effect, if any, on the radii of the ring observed in the screen. So we know the increase in speed result increase in momentum mv square mv, sorry, mv, and whenever there is an increase in speed, if the collision will increase, so the momentum will increase, and when the momentum will increase, so according to the formula, de Broglie wavelength equals Planck's constant divided by the wavelength. So the lambda will decrease because the momentum is increased. So wavelength will decreases. So whenever the wavelength will decreases, so the rings will be concentrated and the radii of the ring will decrease. Now, see, a proton and an electron are each accelerated from the rest through a small through the same potential difference. Determine the ratio. De Broglie wavelength of the proton, de Broglie wavelength of the electron. So lambda of proton, wavelength of electron, and is equal to the Planck's constant divided by the momentum of the proton and the Planck's constant divided by the momentum of the electron. So Planck's constant is the same. So momentum of electron it will be reciprocal out. So it will be momentum of electron equal over the momentum of proton will be equal to the de Broglie wavelength of proton over electron. So it will like that. And we know the momentum is mass of the electron multiplied times mass of the mass of the momentum, right? Is this right? So it's not like this. It's v, right? So I could say it's for example, we say it is mass of electron times velocity of the electron divided by mass of proton times velocity of proton. We know the energy over charge is the potential difference, and potential difference is both is the same for both protons and electrons. So that means E over Q of proton is equal to the E of Q of electron, right? So after having this means energy mv square, right, and charge. This half will be cancelled out, and we will find where we will get what the velocity of the square of proton divided by the velocity of the square of the electron is equals to the mass here and the charge after uh, the cross multiplication. We will get this, right, the velocity of electron. And if I uh, reciprocal it, so V of P will be mass of the proton divided by the mass of electron over the Q of the charge of the electron over the charge of proton, this, right? So if I see this mass of velocity, this one, right? So if I just put within the weight, so it will mass of electron. If I put in the square root, it will be mass of the electron square over mass of the proton square. Here is the catch. Actually, what I did, I just have this, right. So I just multiply mass over here and mass over here, right? Electron and proton, it do the same in this. When I put it into the in the square root, it will be a squared, right? So the equation is balanced. Mass of the electron is square over mass of the proton is square. And here it is mass of the proton, mass of the electron, charge of the electron, charge of the proton. So so this one, it will be cancelled out, right? And we know the charge of electron is having minus 1.6 into 10 power minus 19 coulomb, and the mass of the proton, the charge of the proton is also plus 1.6 into 10 power minus 19 coulomb. So the magnitude will be the same. So it will both will be cancelled out. Only the thing is left is mass of the electron over mass of the proton, root of it. So here we have this. We have equate everything like this. So it will be mass of the electron divided by the mass of the proton under the square root. So the mass of the electron is 9.1 into 10 power minus 31 divided by 1.6 into 10 power minus 27. Root of it, we will get 2.33 into 10 power minus 2, right, into 10 power minus 2. So after rounding off is 2.3 into 10 power minus